Hello, everyone. Welcome to the Data Scientist Show live. Today we have Kristi Angels. Kristi, would you like to introduce yourself?
Sure. Thanks, Daliana. So I'm Kristi Angel and I work at EPO. For those of you who don't know what EPO is, we are an experimentation platform that's warehouse native and powers trustworthy high velocity experiments across product and marketing. I joined EPO as a community evangelist where I get to focus on creating content and building community around experimentation. One of the things that's really important to me is recognizing that everyone starts from somewhere different in experimentation. And so presenting experimentation, best practices, and concepts in an approachable way is just something that is near and dear. And I think that's because I started my career at Groupon also on an experimentation platform team. But our platform was built for product managers who didn't have the luxury of dedicated analytic resources. So, specifically at Groupon and Grubhub, a lot of my work was focused on empowering non-experts to experiment at scale without compromising rigor.
Thank you. Sorry, I mispronounced your last name. I think
Oh,
I
you're
just want more angel in the chat to say
good.
angels.
I'm all of the angels.
Yeah, all the angels. I recently read a blog that says in companies like Google and Microsoft, only 10 to 20% of the experimentations had positive results. Why do you think that's the case?
I think there's a couple of reasons for this. One is just a very human reason. We are not particularly great at predicting what is going to work and what's not. And I think that's just because we are all individuals and we're subject to our biases, our preferences, and we don't always get it right. And I think that's where the power of experimentation comes in is it helps us check our biases. But I think sometimes another reason for that is we get caught in these product development traps sometimes where we see something work at another company and we decide to try it in our own company. But, our user base might be different, our business model might be different. And sometimes we get stuck in these, what's the newest, coolest UI, UX experience, and maybe we should introduce it. And it's not always the best idea, but it doesn't hurt to try it out. That's why we have hypotheses and tests.
Right. And also it's not a bad thing when the experimentations results doesn't go in the direction we expected. That's why we're learning, we're trying new things. And if everything you tested is positive, maybe you're not making bold movement enough.
I
Uh,
agree.
So, because the success rate is not very high, that means we have to run a lot of experiments. And we all know it takes time for us to set up the experiments, collecting data, and making decisions. So, that's why it's so important to know how to improve the velocity of experimentation. So, what is the first thing we need to think about, Kristi?
Yeah, there are definitely technical approaches to speeding up experimentation, but experimentation is not purely a technical endeavor. It's, again, a big people component to what we do. And so I think experimentation works best when your partners are aligned and brought along for the ride. And a lot of the things that can contribute to speeding up experimentation actually happens before the experiment even starts. Just to kind of set the table a little bit, when I think about experimentation velocity, I'm thinking about it from the perspective of from ideation all the way to decision making. What is that timeline? And I think one of the things that I've seen work really well is in the pre-experimentation stage when you're still planning. One of the things we had at both Groupon and Stitch Fix were this centralized experimentation team that was functioning as a like a center of excellence. We had deep subject matter expertise, and we were able to consult with our stakeholders and experimenters to help them plan their experiments. So we held office hours, and on its face, I bet this seems like probably an odd point to make in terms of speeding up experiments. But we have to remember that not all experimenters are experts and not all A/B tests are straightforward and simple. And so when both of these are simultaneously true, we've probably put someone in a very intimidating situation. When you don't have the right resources or support, people tend to freeze up, get like decision paralysis. or make poor design decisions, all of which can slow down experiments. So I think having folks available to help consult on experiment plans, it unblocks experimenters. It also propagates ideas into experiments much faster. It also helps to create like a community where learning is valued and there are no dumb questions. I can't stress enough how important trust is when building experimentation programs. But ultimately, I think people who have the right supports in place just move faster. If people are moving faster, tests are getting launched faster.
Hmm. Yeah. What we need to do before the experiment starts. So, do we just split our samples and then let experiment run? What are some steps we can set up so later it will be easier for us to make decisions?
So there's actually quite a lot that goes into planning an experiment. You have to figure out who your population is. Is it going to be people just on mobile? Is it going to be people on mobile in New York? So figuring out who your population is one of the first steps. But you also have to identify your problem statement and your hypothesis and then figure out which metric is going to help you determine whether or not your hypothesis or the impact of your feature is a success.
And what about metrics?
Yeah. So I f- metrics are tricky, right? Because I think that it's highly contextual and it depends on the business that you're in. So I personally, I mean, there are frameworks that you can use. I don't like to paint broad strokes there, but I think what I can speak to are some mistakes that people make in choosing metrics. I think they tend to choose too many metrics. So, for example, best practices in experimentation, you usually want to keep your decision metrics pared down to one key primary metric, or at most maybe two. Sometimes you're trying to trade off a couple of things. But the reason you want to keep the number of metrics down in your experiment is let's say that you have a simple A/B test, right? And your hypothesis is that by making this change, you expect to see, let's say, a change in conversion rate. That's one hypothesis. But if you add in another metric like revenue, now you have two hypotheses. You expect this feature will change both conversion rate and simultaneously it will change
Right.
revenue.
Mm.
And so now you've got to correct for your multiple hypotheses, and that can reduce the power of your experiment for a fixed sample size, or if you increase your sample size to power both of those metrics, that's going to take longer. So that's one mistake I see in metrics. I think another one that's a big one for me is defaulting to revenue as a primary metric.
Mm.
I think there are definitely some use cases where revenue as a primary metric makes
Right.
sense. I think for a lot of features, it's just too downstream from the actual change that's been made. And it's probably not very sensitive to the feature change. It's also a very noisy metric. So if you are in a business or even a maybe a corner of a larger business with a small surface area, sample size can be a problem. And so variance is going to be an even bigger problem, and revenue tends to be a much noisier metric. So you really want to choose something that's a little closer to the feature and is more indicative of the behavior that you're determining as success.
Yeah, I think that's a great point. If you're changing something very small in the beginning of the funnel, it's very hard to see the impact in the downstream metrics. For example, revenue. Maybe your goal is to encourage customers to stay on the page a little longer, or say maybe adding things to cart or click on another action. So those are something tangible you can track. But I would also say sometimes people would use some those metrics because they know it's easy to move as some sort of vanity metric. It doesn't really help them move the needle. So you need to decide what metrics you're picking that can help you get enough signal, but also mean something for the business, not just because it's easy to move.
Yep.
Another thing I like to add is I think it's interesting to think about revenue because I used to work at Amazon, so we have to track revenue. But I think you brought a good point. It's not always a good idea to look at revenue. For example, very often we'll have revenue as a primary metric and also we'll look at the conversion. So
Mhm.
when team have different goals, so for example, their goal is to just have more customers. So even if revenue is kind of flat, inconclusive, but they increased the conversion rate or say Prime sign up is still a success. And those things we need to decide before we start experiment. So what happens if you have two measures going to different directions or one insignificant, one is significant or negative? Because I sometimes also see teams using revenue as a safety metric to make sure whatever you do, revenue is not down. Yes. Have you seen some of the examples when metrics go into opposite directions?
Absolutely. That's a great point. That goes back into how important pre-experiment planning is. I've seen a lot of experiments kind of spiral because they've had really ambiguous decision criteria. And I think that these decisions are much easier to reason about before you've even begun collecting data. You've identified the metrics that you're going to measure in your experiment. You've separated them into categories. You have your decision metrics, and then you have your secondary or guardrail metrics identified as well. Your decision metrics are the only metrics that you're really considering in a go, no go kind of decision. And you want to enumerate or be explicit about all combinations of those metrics if you have more than one and what you will do in each case. And that's where socializing your experiments ahead of time and making sure that your stakeholders are involved and just really getting super clear about what you will do in each case before you launch an experiment is really critical. I mean, I've worked in a company before where we would have post experiment review, and it was always very clear that the experiments weren't well socialized
Mm.
beforehand because we would have a lot of stakeholders in the meeting, and each of the metrics that we were looking at impacted everyone slightly differently. And I don't think that there was alignment that was driven ahead of experiment launch. What would end up happening is we would get stuck in these circular conversations, and sometimes launch decisions would be delayed by weeks while stakeholders align themselves. And I think a lot of that swirl can be avoided if we're thinking about this strategically from the outset.
Yeah. Do you have some advice on how to pick guardrail metrics? Or maybe for folks who are new to A/B testing, explain a little bit what is a guardrail metric?
Yeah, I like to split metrics up in three ways. So you have your decision-making metrics, and those are really anchored in what would prevent you from rolling out an experiment? So when I'm helping to partner and home in on which metrics are decision-making metrics, I kind of always come back to that question. Would this prevent you from rolling this out? If the answer is yes, then it's probably a good candidate for a decision-making metric. If it's not, then it's probably something that matters to you. You just want to keep an eye on it, but we're not going to include it in the decision-making metrics. And we can talk about that in a little bit in terms of what's too many metrics. So, secondary metrics are metrics that are kind of proxies for the primary metrics. You want to see them tracking together, but if they start diverging in opposite directions in terms of like good versus bad, not necessarily positive versus negative, because, well, they could just mean different things. But when they start diverging, that should get your spidey sense activated, and you should start thinking about diving into the data a little bit more to see what's really going on. Same with guardrail metrics, although guardrail metrics, those are the metrics like latency or things like that that you don't expect to change, but you also don't want to change. I think altogether, secondary metrics and guardrail metrics are, I like to call them hypothesis generating metrics. So when they diverge from what you would expect, It's a good time to do a deeper dive and try to understand why. And then that can feed your learnings for future hypotheses and experiments.
Right. And also, sometimes we will get a dashboard of all the metrics that we didn't even ask for. Again, using the example at Amazon, they will have a category breakdowns. Even if I'm testing something about electronics, there will be breakdown of shoes and fashion, or the category that's not relevant. And you always see some categories up and down, and those are not even in the secondary metrics or guardrail metrics. And what I found interesting was sometimes a product manager or data scientist would cherry pick a
Yeah.
metric from a category and say, oh, maybe this experiment had some positive impact, but if you're randomly shooting a dart, it's going to land somewhere. And I like you mentioned, I think those metrics from some dashboard your company always provide is hypothesis generating metrics. Maybe if you are really curious about it, you can design another metric, use that as a primary metric to see whether it moves the needle. And also, again, ask yourself, is it crucial to your business, or are you just want to make an excuse for you to launch the experiment? Yeah, I think definitely the post experimentation discussion, slicing, dicing the data can sometimes take up even more time than running the experiment. So having a clear objective before the experiment is very important in making the whole process faster. I think previously you mentioned having a support team, having people you can go ask questions, hosting office hours. So, can you talk about for a team to make the right decision, what kind of roles we need?
That's a really good question. And it's tough to answer because I think that there are a lot of different org structures. And I mean, you have centralized data science teams, you have decentralized data science teams. Some companies have product with lots of analytic resources where some product managers don't have any. I think that companies that have the opportunity to work in squads, there was, gosh, I think it was Y Combinator's startup school, a really old video from like 2011 that I watched, where one of the leadership had come in and was talking about how Facebook had made the pivot from, well, they had made the realization that their highest performing teams were teams that had fully staffed squads. So maybe a couple of engineers, a
Mm-hmm.
designer, a product manager, and a data scientist. And the squad was focused on one particular product area. And so when they made that realization, at least at the time, they had decided to shift their entire structure over to that kind of squad model. And I think it makes sense and it works because people are able to have really deep knowledge in their respective product areas and just kind of they have that institutional knowledge of their corner of a company and they're able to just move a lot more quickly without having to constantly be at the whim of dependencies on external teams. I think that other structures that I've seen work are where product teams are empowered and able to move with autonomy, so long as they have sufficient analytic resources. So maybe analytics is centralized and they have some domain expertise, maybe smaller focus areas. And then there's maybe an experimentation center of excellence that comes in and supports some of the edge cases or more difficult types of experiments. So lots of different things that I've seen work. I think it just kind of depends on where a company is and their maturity level and how well they can resource their teams.
Yeah. And I know a lot of data scientists work in silo. They might be the only data scientist or product analytics on the team, and their manager might not be technical.
Yes.
So, how can they get supported if they are working on a team like this?
Ooh, so I've actually worked in that context before. And I mean, it really helps if your manager is curious and invested not only in the growth of the team, but also in their own personal growth. But that's not really a thing that we always get to control.
Yeah.
I think I had the benefit of learning very early in my career the delicate skill of managing up, right? And it requires some diplomacy and a lot of thoughtfulness, but it also requires that bi-directional trust, right? Like your manager has to trust you and you have to trust your manager and have really clear lines of communication so that you can be heard when you need to be heard, but also to be able to expand their domain expertise to be able to support the team in the right way. That's just, I think that's one of those areas where soft skills really pay dividends in data science.
We also mentioned building a knowledge center. Previously, in the team I worked on, I used to publish an internal newsletter to share the success or failure we observe from the experiments other team run, and then we all learn from this kind of collective knowledge base. And what are some best practices you want to suggest about building a knowledge center?
Yeah, that's another really great question. That's something I'm really excited about. It's interestingly enough, one of the reasons why I joined EPO. So I remember early on in my data science career coming upon a paper written by Airbnb about their knowledge repo. Fast forward several years, and I was network on a networking call with my now CEO, Che,
Mm.
and I'd learned that he had built knowledge repo at Airbnb. And we really just thought about building institutional knowledge in the same way. And just for people who aren't as familiar with knowledge repo, it's a tool where you can centralize your experimentation learnings. And this is something that's now built into EPO as well. All of your experimentation learnings are reported in the same way. They're centralized, they're searchable. Anyone can find experiments that have been run in the past, and the right context is there for people to build off of. I think the analogy that I like to use, especially for the academic folk, is when you go to PhD school, for example, and you're trying to start your research, you don't go around asking people, well, has anybody worked on this before? It's in a Google Doc. Did you know Mike
Yeah.
who worked here 7 years ago? And like that's the typical business solution. Whereas in academia, what you would really do is do a search, a literature search, and find the relevant work that's been done before. And then your work kind of stands on those shoulders and you're able to move on in a much more rapid way. And so I think having a centralized knowledge repo is really critical to product development because you are able to go back and see what was done before, how it was done, why it was done, have your assumptions changed. And it enables people to really just keep that institutional memory, not only for like new employees, but also like for ourselves. Like I have a hard time remembering what I did 6 months ago. And
Yeah.
so it's good to have that documentation to go back and have it memorialized so that we have that institutional knowledge that's shared.
Yeah, exactly. I think I've definitely have seen teams running very similar experiments, and if they have know the results from other team, maybe they will design this differently. But not saying if someone run the experiment, you shouldn't run again because your platform might have changed, right? Your feature might have changed, and your product category might be different. I remember I have seen a team focusing on fashion products, so kind of clothes testing the resolution of the image. One is high resolution, the I think control is medium or low resolution, and another team testing very similar things but for kitchen supplies. Of course, the team running fashion products, they found people tend to wait a little bit to see a high quality image, so that feature with high resolution the feature one. But for a kitchen product, people don't really care about image, right? They care about descriptions or customer review. But still having those examples in a knowledge in the knowledge base definitely help other people make decisions. I think it's great that Apple has this built-in feature so you don't have to just copy paste everything on like sometimes on a Google Doc or some Notion book. It's all over the place. And
Right.
also not just for your team to run experiments faster, avoid similar mistakes, also for yourself, right? If you I totally agree. I don't often remember what I did 6 months ago or like last week. So having
Yeah,
those documented is also very useful later when you want to write your own annual review or promotion doc.
for sure. Absolutely.
So maybe we can talk a little bit about trade-offs because when we want to increase the velocity, I think sometimes people want to say, oh, if we add multiple variants, we have more treatments or have more metrics, we can test so many hypotheses in one experiment. People would think that's productive. I think previously you hinted that too many metrics is it's not always productive because you're having more hypotheses. You might also have higher false positive rates. So, how many metrics is too many, and how many variants are too many? How do we make those trade-offs?
Yeah, that's a great question. And unfortunately, there's no magic number here, right? I think that it's actually helpful to kind of take a step back and think in terms of why too many metrics and too many variants are problematic. Well,
Yeah.
maybe not problematic, but why they contribute to slowing things down, right? So, if we talk about variants first, to run a powered experiment, you typically need a certain number of samples to distinguish the signal from the noise. And for those that are newer to experimentation, power, we kind of use power and sample size interchangeably. But what I mean here is power, its simplest form is a function of the baseline metric that you intend to change. So your control variant, its variance, and the minimum detectable effect that you want to be sensitive to. That's why there's no magic number, is because it's context dependent. But and every experiment is different, but you kind of just have to plug in the numbers and see, and then based on your traffic, like how long that will take. Is that feasible? Is it prohibitive? So now bringing it back to the number of variants, let's say we have a simple A/B test, right? Control, one treatment, and we've done our power calculation and we need 1 million samples in control, 1 million samples in treatment, 2 million for the whole experiment. But now we've decided, oh, well, let's add this other variant in that we want to check. That's going to require another million samples. And so now your experiment requires 3 million samples. So that can slow things down a little bit. And that might work for some people. Some people have the samples, some people have the time. Sometimes there's very good reasons for testing multiple variants. So I don't mean to be dogmatic about it, but it's just one of those things you want to be thoughtful about. I also think there's another thing that people miss when they want to maybe test too many things in a variant. So, for example, they're changing the color of a button and the placement of a button and the copy of the button. When
Right.
you combine all of these things together and then want to test multiple variations of that, the thing that you kind of miss is you're not actually able to separate apart the the causal effect of all of the different changes that you've just made.
Hmm.
And so you might know the overall effect of all three of those changes together, but you can't actually attribute the change directly due to the placement or the copy or the color. And if those are things that are meaningful to you, you might want to test them one at a time. And so I think best practices for me, I like to test the core idea first, right? What's the MVP that you're really trying to learn about? Once you've tested that idea and you have a sense of whether or not it's successful, then you can kind of get into a refinement. You've tested, you've learned, and now you iterate. And that's kind of a repeatable process that you go down as you experiment. So that's the number of variants and just kind of the things to keep in consideration there. Number of metrics is a different problem fundamentally. And it kind of ties back to what we were talking about earlier in terms of the number of hypotheses that you're creating. And so each metric is, you're stating a different hypothesis. You're saying, by changing this, we expect to see a change in conversion and we expect to see a change in revenue. And so when you do that, your family-wise error rate changes. So when you first define your family-wise error rate or your significance threshold, your alpha, that's for one test. When you add in another metric, you now have two tests, and that family-wise error rate changes because the number of tests in your family of tests has changed. You basically have to adjust for that. So this is a multiple hypothesis correction. And I think the simplest form that most people are familiar with is the Bonferroni correction, where we adjust the p-values down. It's inversely scaled by the number of tests. But to maintain the same power level and family-wise error rate, this basically puts us into a situation where we need more evidence by way of samples. So again, that's another way that you risk slowing down your tests is by including too many metrics.
Gotcha. So previously, you also mentioned reduce noise. So what are something we can do to reduce the noise, reduce the variance, so we can actually capture the signal?
Yeah, I think the big one here, we talked about different metric techniques to assist with this problem, but this is where we get into some of the more analytical solutions that happen after you've collected the data. And the big one that I think most people are familiar with is Cupid. And so Cupid is basically, I'm really bad with acronyms. I can never remember what it stands for. Maybe somebody can put it in the chat for me, but depending on how your infrastructure is composed. I know at Groupon we had highly aggregated data for us it would have been really difficult to execute on Cupid in an automated way. But it's basically just, thank you, Alicia. It's basically a way to introduce covariates that, pre-experiment that can help reduce the noise in your model. So it's a regression model that helps account for a lot of the variance that you would see in a more naive t-test. Cupid is just basically like a little boost that allows us to reduce the variance a lot faster using the data that we already have. I think if I remember the statistic correctly, up to 65% faster. Although I'd say that's probably one of the drawbacks with Cupid is the sample size is a little tougher to figure out ahead of time, whereas something like a t-test is a lot more straightforward.
Yeah, cool. I think we covered the five factors we want to talk about in terms of increasing the velocity of experimentation. I want to get to some questions, but I also have some questions for you, Kristi. What do you think about the future of A/B testing?
Ooh, future of A/B testing. I think my brain is a little biased here because I've recently shifted from working on in-house platforms to third-party platforms, and it's really shifted my mindset. If you would have asked me this question a few years ago, I probably would have given a very different answer in the sense that when I worked on an experimentation platform in house, I had the mindset that our product portfolio complexity was just too different and too great that no third party platform would be able to keep up with like our needs and how we experimented. But I think that the methodology that was considered advanced just a few years ago has become much more commonplace,
Hmm.
and the data landscape has changed so much. Well, not everyone's, but the modern data stack makes experimentation and metric definitions so much more easy.
Yeah.
And I don't know, I was talking with one of my coworkers a couple weeks ago about whether or not we think that third party platforms will replace internal teams.
Hmm.
And the more I think about that, I think for some folks who have like your Metas and your Google, they've got a lot of resources and it's very ingrained in their culture. And I think it's probably a different problem. But for most teams, I think that experimentation teams are very expensive. And I don't think a lot of folks realize the complexity that goes into not only building an automated in-house platform,
Yeah.
but also the amount of continuous support that it requires the tech debt that you incur. And so when I think about something like EPO, I'm just like, oh my gosh, this would have been a no-brainer and it would have put our platform out of business in no time. But I also think it's kind of a cool space to be in these days because when you work in an in-house team, I think one of the biggest problems is trying to get buy-in to build new methodology and the new cool shiny things that help experiments run faster because the people that you're trying to get buy-in from they don't understand experimentation at a deep level.
Mm.
Whereas now there's this experimentation platform space that's highly competitive. And so at a place like EPO, it's our focus and our job to build the new, cool, shiny things that will help people experiment faster and more rigorously. And yeah, I think that experimentation platforms have come a long way, and I'm curious to see how things change.
Yeah. I remember when I was working on a external customer of AWS, they want to build their internal experimentation platform in 3 weeks or something. And I had to tell them, hey, I used to work on an experimentation platform at Amazon. We have a team of like 20 engineers and five or 10 data scientists and researchers. It's not something you just turn on some randomization engine and then can run your experiment. A lot of people ask recommendations for courses, books, resources. Maybe you can share, say, the top three resources you would recommend.
Yeah, the first resource that comes to mind is Ronnie Kohavi's book,
Trustworthy online
Online Controlled
experimentation.
Experiments.
Yeah.
Yep, thank you. And that's not gonna tell you how to run experiments, but I think it does
Mm.
really address a lot of the nuance about running an experimentation program that might not be immediately obvious. So I think that gives a really good overview of the complexity of experiments and some of the more surprising things. In terms of learning about how to execute A/B testing and different experimentation methods, I think that space has grown tremendously. I know back when I started my career in 2016, I was interviewing at Groupon, and I'll be honest, I don't think I really understood what the job was that I was applying to because I just never heard of experimentation in industry before. I had a very clinical view of it. And unless you knew who Ronnie Kohavi was, it was just really tough to find things. So one, again, Ronnie Kohavi is a very prolific writer in this space, and he and the Microsoft team have written a number of papers that are just continue to be invaluable to this day. So I recommend checking those out. But also, I love to follow different companies' blogs who are really deep into the experimentation space, like Netflix, Airbnb, DoorDash writes a lot of papers, and those are a little bit more applied and pragmatic. Although I have to say that some of them just recognize the difference of where your company is and where something like DoorDash is in their journey. I think that it's cool to keep up with all of the current state of the art stuff, but when you're just getting started, a lot of times that's just not what you need yet. And start simple and build on from there as you need to.
Yeah. Thanks for sharing that. And Lee asked the question, I think that's very interesting. So basically, if we don't have enough traffic, how can we speed up our experimentation?
That's another really good question. Low sample size experiments are tough. I can speak to how I've managed them in the past. I think that when I've run experiments with low sample size, we have tried to do no harm experiments, so non-inferiority tests, which is basically saying we will roll this out so long as the impact is not any worse than some lift. And it's really tough to do. It's a tough space to be in. Yeah, I'm not sure that I have a lot of really good answers there. I mean, I think that some information is better than no information, but sometimes you just really have to wait for a critical mass in terms of sample size to really be in the experimentation space.
Yeah, I think it's definitely a tough situation when you don't have enough traffic. I think sometimes if you when you can do some power analysis calculation, if you feel you couldn't get enough power, maybe that's not a good time to run your experimentation. You can do other things, for example, like a focus group to leverage the power of small data. And I think the last questions I want to answer is what are some interesting or unexpected cool things product testing you can recall in your career?
I wish I had an interesting answer for that question, but I can't think of anything off the top of my head.
No, no worries. Maybe I can share like a story. Then, if there's something come to you,
Yeah.
share. So I remember with Amazon's product details page, there's a team testing a font that I literally couldn't tell the difference between treatment and control. It's a very subtle change. And then that small change, I think, generated, I don't know, maybe millions, tens of millions of revenue. And even our design researchers, designers couldn't really figure out why. I think some assumption is sometimes the new font aligns the lines better. So if you see something is more aligned, maybe you have more trust in the website, in the product. And I just think on an individual level, it's very hard to think about, oh, I'm going to make more purchases because of this font. But if you think about the scale of experimentation, Amazon reaching millions of customers. So sometimes even a small change can make a huge difference. So that's something surprising.
I
I
think that's a really great example that brings it full circle to the first question that you asked me about why do we think that the success rate of experimentation is only about 20%? And that just kind of goes back to people aren't very good at predicting what is going to be successful.
So before we wrap up, what are some interesting, exciting things you're working on right now?
Yeah, I have just pivoted roles entirely from being a pretty hands-on data scientist to now I am a community evangelist. So I think everything is exciting and new, but I'm trying to write a lot of content that helps make experimentation more accessible to folks, how to create an experiment plan, which I think Alexa linked to. I'm doing a lot in terms of building community. Right now, I have a small pilot group kicked off of experimentation leaders who have worked in spaces where they've seen experimentation at scale work well, and now they're in a small to medium business space trying to scale their own experimentation programs. It's really kind of interesting because there's a ton of resources out there for folks who work in large companies, but not a lot of resources for people who are in the smaller spaces trying to grow their experimentation programs. And yeah, I'm just thinking a lot about how I can extend that community to the masses. If learning about experimentation and community is something that's interesting to you, I encourage you to reach out to me on LinkedIn. I'd be happy to have a conversation.
Yeah. Thank you, Kristi, for coming to our Data Scientist live show. And I'm sure you all have some follow-up questions. You can reach out to Kristi on LinkedIn, and also you can create a free account. All right. Thanks again for coming. I'll see you at the next Data Scientist show live. Thanks again, Kristi and the Apple team. Bye.